Hello everyone, my name is Christian Garcia Ponce. I'm a first year PhD student here at the College of Engineering. My major of study is mechanical engineering, and what I'll be talking about today is the object detection vignette, or more specifically, the computer vision module family. So what I'm going to start here momentarily is an open source computer vision model that we found online. So you should see it start to come up here in a few seconds, and it'll start to recognize a few things in the room. So as you can see, it's starting to recognize some of the people in the room, a few of the different objects, and these are helpful because once you have it running and recognizing different things it's been trained on to do, you can then use it to do more helpful tasks. So as I'll go on in a moment, this environment that we created allows you to deploy these models pretty easily, as well as train and label some of your own data. Additionally, we also introduced some manufacturing applications that people can use for their own industry. So the current model that we're running right here is showing some of the objects in the room. Additionally, it can also recognize this bottle, for example. Should recognize it soon. The chair in the background, the people, TVs, basic things like that. Additionally, you can also train specialized models to recognize certain pieces in your environment. So what I mean that usually consists of a labeling step to label the object that you want to recognize, and then training your model on a couple of different of those images, examples of those images. So for example, if I wanted to label this image here, I would have to draw a boundary box around this person and let the system know that this is a person. So I can draw the box, label it person, and if I were to do this for a bunch of different images or a bunch of different objects, we'd slowly start having enough data that we could train a model. So after we label all our examples that we want to train a model to recognize, we can then move on into the model training. So here in this environment that we created, it's a lot more intuitive of a way to do a lot of these tasks. Normally you would have to do this through a Python script or some kind of coding language interface. This allows you to start getting familiar with the technology without having to really know a lot of how programming works. So in this training phase, what you can do is you can take those images that you already labeled with its boundary box and its object label, and you can start setting some of the training parameters. So what I mean by training, it's the same way that the gym. You have to do a lot of different sets and some training over time, and that's basically what the computer system is doing. You give it a bunch of examples of images that you're going to want it to learn on, and you're going to give it a certain amount of times that it has to do those sets. And after doing those a certain amount of times, you slowly get a model that's a little bit more robust for doing what you want it to do. So I'll move into back to where we were running our previous models and show an example of a model that we trained specifically to recognize one of the parts that we have here. So this model here and the previous model that I showed you guys, it would not recognize it because it was not in its training data. However, we're interested in recognizing the different components of it. So what we did was we took its housing, its internals, a couple of the pieces that make up this completed smart plug, and trained it to recognize the various steps so we can then do some pretty cool things with it. So I'll start running it momentarily. And as you can see, it's as simple as just clicking a few buttons, adjusting how confident you want the model to be. So when I say confident, it's how sure it has to be to tell you that it thinks it's an object. And then just some fancy things like changing the size of the color of the box that it makes a certain object. So shortly, I'll start running the previous model, and I'll turn the camera down so I can see the parts that I wanted to look at. Give it a second to focus. There we go. And you can see that it starts to recognize the different components we trained it to do. It's recognizing the housing, the internals, the cover, the button cover, and then ideally it should also recognize a completed plug when it sees one. So these are just a few examples of how you can use some pre-trained models and then train your own. Some of the scenarios that it's more helpful in manufacturing are here. So one use case for a lot of manufacturing is defect detection. So in the example that you can see here, it's videos of a assembly line where something either has a label or is missing a label, and then it can quickly notify somebody, hey, we have a certain amount products that have these defects that we need to address. Additionally, you can also monitor other parts of a process, like this one's recognizing where there is chickens, where there's not chickens, if there's bad chickens, very similar to the missing label before, but instead of recognizing for, looking for a defect, it's really counting how many objects are there. And that kind of leads into the second scenario where we have, you can use a camera mounted on some kind of object going around a facility to count how many of a quantity of items that you have. So in the example that I'm showing here, it's going around driving a warehouse and counting how many boxes are in each pallet. So instead of manually and tediously having to count each one of those pallets, you can now have a camera system just easily do it with you from going around and recording a video. Another place that computer vision is very helpful is for worker safety. So in the example that I'm showing here, there's an area near an industrial robot where people are supposed to have a certain amount of protective equipment. So the computer vision models quickly recognize when somebody doesn't have that protective equipment and it's able to shut off the robot or notify that person, hey, you need to have this particular equipment to be around this area. The last scenario that computer visions can be used for is a lot of equipment monitoring, or as you'll start to notice very quickly, there's a situation that breaks out and the computer vision model is able to detect it before it gets a lot more out of hand. So it slowly starts to recognize an electrical fire within this equipment and is able to notify either the fire department or somebody close by, hey, we have an issue at this station. So those are just a few of the ways that computer vision can be utilized in manufacturing, as well as also being pretty fun to play with. So I've been Christian. Thank you for your time.